Here we have to derive Hamilton's canonical equations. It is a known fact that the Hamiltonian is a function of position, momentum and time, whereas the Lagrangian is the function of position, velocity and time. Now we have to find out the value of dh. If h is a function of position, momentum, time, the value of dh equal to dou h by dou qj into dqj plus dou h by dou pj into dpj plus dou h by dou t into dt. Assume that this is equation 2, this is equation 1. But from our Hamilton's function, according to Hamilton's function, the value of h equal to pj qj dot minus L. From this we have to find out the value of dh. dh equal to pj dqj dot plus qj dot dpj minus dl. So this is equation number 3. As pointed out earlier, Lagrangian is the function of position, velocity and time. From this we have to find out dl. dl equal to dou L by dou qj into dqj plus dou L by dou qj dot into dqj dot plus dou L by dou t into dt. This is the value of dl. But the value of generalized momentum p suffix j equal to dou L by dou qj dot. This is our generalized momentum. For a conservative system, the Lagrangian equation is d by dt of dou L by dou qj dot minus dou L by dou qj equal to 0. This is a Lagrangian equation for a conservative system. From this, d by dt of dou L by dou qj dot equal to dou L by dou qj. But dou L by dou qj dot is our pj, then d by dt of pj equal to pj dot. Then this is d by dt of dou L by dou qj dot is our pj, which is equal to pj dot, that is equal to dou L by dou qj. So in this relation dl, dou L by dou qj should be replaced by pj single dot, then dou L by dou qj dot is replaced by generalized momentum p suffix j. Now dl takes the new form p suffix j dot dqj plus pj dqj dot plus dou L by dot t into dt. This is the value of dl. Now equation 3 becomes dh equal to pj dqj dot plus qj dot dpj minus of this dl. pj dot dqj plus pj dqj dot plus dou L by dou T into dt. Close the bracket. This is equal to pj dqj dot plus qj dot dpj minus pj dot dqj minus pj dqj dot minus dou L by dou T into dt. See here, pj dqj dot is in plus sign. Here pj dqj dot is in negative sign. So these two terms are cancelled out. Then the value of dh equal to qj dot dpj minus pj dot dqj minus dou L by dou T into dt. So this is equation 4. Now we have to compare the coefficients of dpj, dqj and dt. See the equations 2 and 4. From equations 2 and 4, on comparing the coefficient of dpj, here the value of dpj is qj dot, here the value of dpj is dou h by dou pj. On comparing the coefficient of dpj, we can get qj dot, which is equal to dou h by dou pj. Then consider the coefficient of dqj. Here the coefficient of dqj is minus pj dot. Minus pj dot, which is equal to, here the coefficient of dqj is dou h by dou qj. Dou h by dou qj. Finally, we have to compare the coefficient of dt. In equation 2, the coefficient of dt is dou h by dou t. In equation 4, the coefficient of dt is minus dou L by dou t. Therefore, we can write dou h by dou t, which is equal to minus dou L by dou t. These are all called Hamilton's canonical equations.